Hello everyone, this is Ms. Chelsea and today we will be discussing the power rules. Our objective for today is that students will be able to manipulate expressions where an exponent is raised to a power. Let's go ahead and start with an example, g squared to the fourth power. Let's go ahead and fully expand the expression. So first of all, g squared to the fourth power means that there are 4 g squared multiplied together. And each of those g squared is the same thing as g times g. So overall, we have g times 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 g. Or, if you condense that expression, it is g to the 8th power. Let's go ahead and look at example 2. H to the negative 6, all raised to the 5th power. First, let's partially expand the expression. So we're going to have h to the negative 6 5 times, which is h to the negative 6 times 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 h to the negative 6. Next, we're going to use the product rule to condense the expression. So h to the negative 6 times h to the negative 6 is h to the negative 6 plus negative 6, or h to the negative 12. We can keep doing this to get h to the negative 18, h to the negative 24, and h to the negative 30. Each time, we consider the previous product and multiply by h to the negative 6 again. Alternatively, we could just use our product rule but expand it to include all the terms. So h to the negative 6 plus negative 6 plus negative 6 plus negative 6 plus negative 6, which is h to the minus 30. Either way, we should arrive at the power rule, which states that when a base and its exponent are raised to a power, it is equivalent to raising the base to the product of the two powers. So a to the m to the nth power equals a to the m times n. As in the previous example, h to the minus 6 to the 5th power is the same thing as h to the minus 6 times 5, or h to the minus 30. Now let's try using the power to a power rule in an example, 2 to the 3rd all raised to the 3rd power. According to the rule, this should be the same as 2 to the 3 times 3, or 2 to the 9th power. That is our expression in condensed form. In order to write the expression in standard form, we're going to expand that out and then multiply. So 2 times 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 2. This is 2, 4, 8, 16, 32, 64, 128, 256. 512. 2 to the 9th is the same thing as 512. Let's look at example 4, x times y to the 4th power. So first, let's expand the expression out, xy times xy times xy times xy. Next, we are going to use the commutative property to get variables together. So x times x times x times x, and y times y times y times y. Lastly, we're going to condense the expression, so x to the 4th times y to the 4th. Remember, you can write the multiplication sign in the middle, but you do not have to. This actually shows the power of a product rule, where the power of a product of 2 or more factors is the same as the product of the factors, each raised to the power. So, for 2 or more different bases, if the power is the same, then a to the n times b to the n equals a times b, all raised to the n power. Let's go ahead and try another example. 1 over 5 to the 3rd power. First, let's expand the expression. 1 over 5 times 1 over 5 times 1 over 5. Now, we're going to need to multiply the fractions. So 1 times 1 times 1, or 1 to the 3rd power, is in the numerator. And 5 times 5 times 5, or 5 to the 3rd, is in the denominator. So, in condensed form, you have 1 to the 3rd over 5 to the 3rd. Now, if we wanted to write this in standard form as a fraction, we would multiply it out and get 1 over 125. This is an example of the power of a quotient rule. The power of a quotient is the same as individually raising the dividend and divisor to the same power. The fraction of 2 different bases with the same power is a to the n over b to the n equals a over b all raised to the n power. That's all, folks.